Hello everyone, welcome to this video. In this video, we'll be learning about the corollary of fundamental theorem of group homomorphism that we have studied in the previous video. So here this result tells us that if phi is a homomorphism from a finite group G to G bar, then the order of phi of G divides both the order of G and the order of G bar, correct? So we are given phi from G to G bar is a homomorphism. Then whatever is this image of G under phi, which is a subgroup of this G bar, right? This is the order of this divides both the order of G as well as the order of G bar. This is the result. So now how we can make use of this fundamental theorem of group homomorphism? Let's have a look here and proceed with the proof. Right, so we first of all know that if H is a subgroup of G where phi is given to be a homomorphism, right, then phi of H is a subgroup of G bar. This is a result that we have already studied, right? Moreover, by the Lagrange's theorem, we know the order of a subgroup divides the order of group, combining both the results, because you know G is a subgroup of itself, right, being a trivial subgroup. Therefore, phi of G has to be a subgroup of G bar under phi, which is a homomorphism according to this first result, correct? Now, moreover, if phi of G is a subgroup of G bar, therefore the order of phi of G divides the order of G bar, correct? So let's mark this as equation 1. Now, moreover, you know that for a finite group G and a normal subgroup N of G, this G oblique N, this always forms a factor group or a quotient group. So, and we also have studied by the Lagrange's theorem that the order of the group divided by the order of the normal subgroup is basically what? The order of the factor group. So combining these results here, and moreover, by the fundamental theorem of homomorphism, you know that this factor group, which is generated by the kernel of the given homomorphism, is isomorphic to the homomorphic image of the group under phi, right? So using both these results, now we can have a second result which to prove that phi of G divides the order of G, right? The order of phi of G divides the order of G. This is what we wanted to prove next. So you know phi of G is isomorphic to this factor group. Hence, its order would be equal to its order. The number of elements would be the same in both of them because they are bijective mapping. Their isomorphism means they are 1, 1 on 2. Hence, they are bijective. So they would have the same number of elements within it. Now using this Lagrange's result here, we have this equal to the order of G divided by the order of kernel phi, and because you already know this kernel phi is a normal subgroup of G. So from here you can clearly see that the order of group G divides the order of the group G. The order of phi of G divides the order of G. Hence, you have your second relation from here. So from these two relations, you have the order of phi of G dividing the order of both G as well as G bar. And this is what you wanted to prove in this particular result. So I hope you understood this video well. Well, that is it for this video. Thank you for watching.